Here's a hard rate problem. Hannah's taxi company charges a fixed flagfall amount plus a fee per kilometre travelled. Daniel was charged $17.50 for an 8-kilometre journey. Matthew was charged $23.50 for an 11-kilometre journey. You have to determine the flagfall amount and the rate per kilometre. That looks hard, doesn't it? We don't have the information we usually start with. But it's not actually difficult. What would we normally do to solve a rate problem like this? We'd draw a graph. Do we have enough information here to draw a graph? I think we do. What are our two variables here? We've got distances and costs. Which one depends on which? Does the distance we go depend on how much we pay? Or does the amount we pay depend on the distance we go? The second option. So we want a graph with cost on the vertical axis and distance on the horizontal axis. Now, do we have any points to put on our graph? Yes, we do. Daniel's 8-kilometre trip cost him $17.50. Matthew went 11 kilometres and was charged $23.50. Okay, so draw a line through those 2 points. We don't have a third point to check our accuracy, so do it as carefully as you can. Now, we want to find the flagfall amount and the rate per kilometre. The rate is going to be the gradient of our line, and the flagfall, the initial amount, is going to be the y-intercept. So how will we work out the gradient? I want to be as accurate as I can, and there are actually 2 points on this line that I know exactly where they are. So let's use those 2 points to calculate the gradient. The rise is from $17.50 to $23.50, a rise of $6. And the run is from 8 to 11, which is 3 kilometres. So the gradient is rise over run, $6 over 3 kilometres, which is $2 per kilometre. That must be the charge rate for Hannah's taxi company. The gradient is the rate. And the flagfall is the y-intercept. How will I determine that accurately? I might not have drawn my line quite right, and I haven't got any grid lines there to help me. How can I use what I already know to work out the y-intercept exactly? Well, that point is 8 kilometres less than the first point I actually know, which is Daniel's journey. But the gradient says that the cost goes up by $2 for every kilometre of distance. So the cost must have risen by 8 times 2, or $16, over the same section on the graph. What's $16 less than $17.50? It's $1.50. So the y-intercept, which is the flagfall fee, is $1.50. Can you write an equation that gives the trip cost for Hannah's taxi company based on the distance travelled? The dependent variable is equal to the gradient times the independent variable plus the y-intercept. The trip cost equals $2 times the distance plus $1.50.